And hello to everyone. In this class we are going to discuss about the mesh analysis. So first we'll start with the steps we have to follow while doing the mesh analysis. First we will identify what is a mesh, right? Mesh is a loop that does not contain any other loop within it. Okay, so if I say this is a loop, I take a circuit, right? A simple circuit I am taking, right? So I can say this is a loop, this is a loop, this is another loop, this as a whole can be said as a loop. Okay, so this circuit has 3 loops. So in what way the mesh is different? Mesh is also a loop, but it should not contain any other loop. Okay, in this case, if you see, this is a mesh, this is another mesh. Okay, this circuit has 3 loops and 2 mesh. Clear? Okay, so first thing, we have to understand what is a mesh. Mesh is a loop that does not contain any other loops within it. Then what are the steps to be followed? First we have to identify the number of meshes. Okay, find out the number of meshes, which is n number of meshes. Then for each mesh you assign the currents like I1, I2, I3, I4, like that, right? And then apply Kirchhoff's voltage law for each of the mesh. Then write the voltage in terms of current using Ohm's law. We know if your voltage is there, in terms of current means I times R. This is the Ohm's law. Okay, then solve the equations, solve the n simultaneous equations, you will obtain the mesh currents. So if you go for mesh analysis, ultimately you will be finding out mesh current. Okay, now we'll solve the first problem. We have a simple circuit. We have to find the branch currents. Okay, IA, IB and IC. So we go for mesh analysis. So what is a mesh analysis? How many meshes are there? We have 2 mesh. This is the first mesh. The current flowing through the first mesh is, let me say, I1. The current flowing through the second mesh, let me say, I2. Okay, so we have 2 mesh. So n equal to 2. So mesh currents are I1 and I2. Okay, then what you have to do? You have to apply Kirchhoff voltage law for first mesh, for mesh 1. Okay, what does Kirchhoff voltage law states? For the first mesh, you have to write the voltage in the loop as equal to 0. Okay, so the current, you say, the current I1 is entering the minus of the voltage, right? So it is minus 15 volt plus the voltage drop across, let me say this is V1, let me say this voltage as V2. Okay, so minus 15 plus V1 plus V2, then plus 10 is equal to 0. Okay, so this is the Kirchhoff voltage law for the mesh 1. Now write the voltage in terms of current. What is V1? That is a voltage across 5 ohms. Okay, so what is the current flowing through 5 ohms? It is I1. Okay, our objective is to find IA, IB and IC. But using mesh analysis, we will find mesh currents I1 and I2. Later we will find out the branch currents IA, IB and IC. Okay, so V1 is nothing but current times current is I1 multiplied with the resistance 5. What is V2? That is the voltage across 10 ohms. Okay, the 10 ohms is between the 2 meshes. If you see, the 10 ohms is between 2 meshes. Okay, mesh 1 and mesh 2. So both the currents are flowing. I1 is, if you see, the I1 is entering the plus of the mesh, but the I2, this I2 is entering the minus of the 10 ohms. Okay, so the net current is I1 minus I2 times 10 ohms plus 10 is equal to 0. So on solving this, so it is minus 15 plus 5 plus 5 I1 plus 10 I1 is 15 I1 minus 10 I2 plus 10 is equal to 0. So minus 5 plus 10 is minus 5. Bring minus 5 to the right side, it will become plus 5. This is the equation 1. Okay. Now similarly, apply Kirchhoff voltage law for the mesh 2. For the mesh 2, we have to write with respect to the second mesh. In this case, I will write the voltage as, let me put plus minus, plus minus, plus minus. Okay, this is the passive sign convention we will be writing. Okay, so let me say the voltage drop for the mesh 2, this is V3. This would be like, let me give the name V4. Let me give the name, the voltage drop is V5. Okay, so the current is entering minus 10 volt. So it is minus 10 plus V3 plus V4 plus V5 is equal to 0. Okay, so what is V3? That is the voltage drop across 10 ohms with respect to mesh 2. So I2 is entering the plus, I2 is entering the plus, where I1 is entering the minus. So it is, the net current is I2 minus I1 times 10. What is V4? Current I2 through 6 ohms, the current flowing is I2 and the resistance is 6. What is V5? The current flowing is I2 and the resistance is 4, is equal to 0. Okay, so it is minus 10 plus 10 I2 minus 10 I1 plus 6 I2 plus 4 I2 is equal to 0. So you add, so it is minus 10 I1, 10 I2 plus 6 I2 plus 4 I2, it would be 20 I2. Bring minus 10 to the right side, it becomes plus 10. This is equation 2. Okay, the third step would be solving equation 1 and 2. Solving equation 1 and 2, you should be getting I1 as 1 ampere, I2 as another 1 ampere. Okay, this would be your answer, right? Okay, now I give a practice problem for you. You try this out. Okay, the question is not yet solved. We have just found out I1 and I2, right? We need to find IA. What is IA? IA is the current flowing through the branch 5 ohms. So by observation, we can clearly say IA is equal to I1. Okay, what is IB? The current flowing through 6 ohms. So IB is equal to I2. Right? What about IC? IC is the current flowing through 10 ohms. Right? So it is flowing from top to bottom. If you see IC, it is flowing from top to bottom. So I1 is flowing from top to bottom, or I2 is going in the opposite direction. So IC is I1 minus I2. Okay, so with this in mind, we can write IA is equal to I1, which is 1 ampere. IB is equal to I2, that is also 1 ampere. IC is equal to I1 minus I2, so 1 minus 1, it is 0 ampere. These are the branch currents. Okay, now I'll give a practice problem. You take another circuit. Okay, right. So the question is, find the mesh currents. They are given the mesh currents as I1 and I2. Find mesh currents I1 and I2. Okay, so how many meshes? 2 meshes. So 2 mesh currents I1 and I2. So you apply KVL for mesh 1. Okay, right. So what about for the mesh 1, where I have to put the voltage? You see here, plus minus, plus minus, plus minus. This is the voltage. Okay, right. So if you take the voltage drop across 4 ohms, it would be 4 times of I1, then minus 90 volt plus 6 times of I1, plus for the 10 ohms the I1 is entering the plus where I2 is entering the minus, so the net current is I1 minus I2 times 10 is equal to 0. So it would be, if you add, it would be 20 I1 minus 10 I2 equal to 90. This is the equation 1. Okay, now we apply KVL for the second mesh. For the second mesh, let us give for the passive sign convention notation, this is plus minus, this is plus minus, this is plus minus. For the second, the current always enters the positive of the resistance. Okay, the voltage will be positive while the current is entering. That is called passive sign convention. Okay, so it would be 40 volt plus 5 times of I2 regarding 10 ohms. I2 is for the mesh 2, I2 is entering the plus, I1 is entering the minus, so it would be I2 minus I1 times 10 plus 15 I2 is equal to 0. So it would be 5 plus 10 plus 15, so it would be 30 I2 minus 10 I1 equal to minus 40. So I can write this as, multiply both sides with minus. This would be the equation 2. Okay, solving these two equations, solving 1 and 2, you should be getting I1 as 4.6 ampere, I2 as 0.2 ampere. Okay, right. Thanks for listening. In the next video, we will deal with the super mesh. Thanks for listening.